Hi, I'm Mark Wilson, the Engineering Heretic, and following on from my tutorial thing on making gears on a CAD system, I'm just going to show you what you can do with the existing gear I made, which is a 41 tooth gear. Well, we would like to see what we can do to manipulate that to other numbers of gears. We're going to look at a 13 tooth gear. We're going to modify this particular CAD model to suit a 13 tooth. And in CAD, if you design something correctly, it's very easy to modify. And when I went about coming up with this particular design that I did before, I was very careful to make sure that I had a few things locked in place. But that's the CAD system, and that's a little bit different than what we want to talk about here. But if you design something correctly, it's very easy to modify. Now, it's 41 tooth gear we have here, and we would like to make a 13 tooth gear. So let's have a look at the Mr. Unwin's thing from Model Engineer, and we'll have a look at that. We did a 41 tooth gear. We're up here before at cutter number 3. Now we're going to choose cutter number 8. For a 12 or a 13, we're doing a 13 tooth. And of course the pin diameter is a lot smaller, making a tighter radius around here. And also the pin centers are different. They're narrower, and the feed-in is also different. So what we want to do is go to our CAD model and modify this to suit a 13 tooth gear. So I've got this on my CAD system now. I'll call this up. And first of all, we need to change the diameter of the blank to suit a 13 tooth gear. So we'll go to the sketch that made that overall diameter. And we'll edit this one here. Okay. Now, as I said before, I use a 41 tooth, and I added 2 to that, which gives me the overall diameter. We're doing a 13 tooth, so this size here, the number of teeth just in metric module 1 determines the diameter, of course. And what you do is a 13 tooth will give you, if you make the diameter for a 13 tooth, it will give you the pitch diameter, which is the center of the tooth from the top to the bottom, which is 2.25 millimeters. But in order to do get the overall tooth, you have to add 2, which is 1 mil to both sides of the gear to give you the overall diameter. So doing a 13, so we'll double click on this one here. It's on select, yes. Okay, we're going to make that 13 plus 2, which is 15. Okay, and we'll save that. Okay, there's our little, we have made that, that's our blank. And now we need to edit the sketch that made the tooth profile. So at the moment, my CAD system suppresses the everything from what I just edited down. Your CAD system may continue on and do the whole thing, but if I extended that to the last figure, it would look rather strange because it's missing a whole bunch of things. But we'll move this back up again to this sketch here. We'll edit that sketch. Right, now there's our, this is the same sketch we used from Unwin's chart thing. Let's change the pin centers. So on our chart, we've got our pin centers here, which is pin centers is 5.267. So let's click on that one there. 2, 6, 7, and accept that. And our diameter, now these two diameters here, they're linked together, so they will be the same size. Our diameter of our pin diameter is 4.1. Double click on that one there, 4.1. Enter that. And of course our feed in is different as well. That formula remains constant. The feed in is 2.251. So let's have a look at that. One. And there we go. And I believe that looks correct. Yeah, I'm happy with that. Get out of my sketch. And of course, we had 41 teeth. This time we want to change the pattern there. So let's go back and have a look at that in 3D. Now I just need to modify at the moment on this particular, the pattern of that going around there was 41. We need to change that to 13. So we'll just edit this one here. And we'll need to change it because at the moment it's 41. We need to change that to 13. So everything else is the same. We just change that to 13 and enter. And of course, there's my gear, the 13 tooth in metric module 1. All right, so there's my tooth. Now there's a few issues with this particular model, and CAD models. You can do anything in CAD, but not necessarily do it in the real world. If you look at, let's look at this straight on. Going a bit tighter. You'll see here my tooth. Of course, the radius is quite pronounced now, and it looks like, and it does, go. Your cutter that came and cut this would undercut in that area there. Well, you can't do that. It would make that straight. Remember, I did not put in the radius in the corner that this gear would normally have, as normally a 0.25 radius. That would come up to around about there. So at about a 12 or a 13 tooth, this is a cutter that will do a 12 or a 13. There would also be a radius at the bottom there, and this would most likely not undercut. And that's why anything less than 12, you find there's all sorts of problems with undercutting of the teeth, and you can't necessarily make that particular gear. So I would doubt that the 10 tooth gear would be a very effective, whether you make a cutter that would work terribly well with that. But Unwin's got it in his chart, but this is why these cutters only usually go down to a 12 tooth. Okay, so of course, if you put the little radius in there, that would probably make that okay. So that's and there we have a 13 tooth by just modifying the data we had before. Right, that's in metric module 1, and if you could 3D print that and to make a gear out of plastic, or you could get the correct cutter and machine that particular gear. There's any number of ways of making a gear like this. If I was in CAD, like in making say a metric module 2 gear, I would need to basically expand or scale this, and I do have a scale or mirror this part. I can do a uniform scale, and my scale factor is 1. Let's change that scale factor to 2. And OK. And now we have a metric module 2 gear by just changing the scale factor. So in essence, we can make any particular gear we want by just changing the scale factor. Let's supposing we were going to have, we wanted to make this a diametral pitch 1, which is actually a very huge gear. At the moment, our scale factor is 2. We know that in metric module 1, we need to convert that to inches. If I multiply that by the scale factor of 25.4, we now have that. And then we have a very large gear. Of course, we'll hit the scale button. We'll see that there. And there is a diametral pitch 1 gear. Of course, that's huge. And that's why in metric module, they're quite small. That 1 is 3.14 is 2.25 in the height. Quite a small tooth. In diametral pitch, it's 2.25 inches, quite large. And normally so diametral pitch we normally multiply, and diametral pitch we usually divide, making a smaller tooth. So if I want to make that the diametral pitch now by a diametral pitch 6, I could also scale that back now, go into scale model again, despite the factor. And I could change that scale factor to whatever. I could save that the way it is and do another scale on top of that. Dividing that whole thing by 6 would give me diametral pitch 6. So that way I could make any particular gear I want in diametral pitch or metric module by using just the same CAD model and modifying it. And thanks very much for watching.